Lesson 6.3 is binomial radical expressions. So binomial are two, which means really a big focus of today is adding and subtracting. Okay, reviewing or learning how we add and subtract radicals. But besides that, we're also going to be multiplying and dividing binomial radical expressions. Okay, so as review, notice what it says up there. Radicals must be like terms in order to add or subtract the coefficients. What do you think we mean that radicals must be like terms? Huh?
They must have the same basis.
There's like
The next one, all the things.
the squares have to be the same, like square, cube,
Or they both have to be like cubed or fourth root.
That's usually what they said.
Okay, so they have to have the same stuff is what I heard. I heard they have to have the same bases. So when we're talking about bases, we're talking about the number inside the radical has to be the same. And then besides that, we also have to have the same roots or indexes. If it's a square root, it has to be another square root. If it's a cube root, it has to be another cube root. So pretty much the radical part has to be identical. Okay, so let's practice with a few of these. Any thoughts on example A about 3 square root of 5x minus 2 square root of 5x? Gonna subtract. Now,
Are we going to subtract the 3 and the 2?
yes.
Would it just be 1 square root of 5?
What I was going to do is my correlation here. What's 3x minus 2x?
X.
1x or x, right? So in this case, you're doing 3 minus 2, and then what's tagged on is the square root of 5x. So what is 3 minus 2? 1, and then square root of 5x. So you could say 1 square root of 5x, but even better would be to say square root of 5x.
Easy. X squared root of
X.
Are we okay with that example?
Yeah.
nothing.
The next one is
Okay.
kind of.
So let's look at B now. B is 6x squared, square root of 7, plus 4x, square root of 5.
You can combine them because they don't have the same.
You can probably combine the square root.
Yeah.
Can you combine the square root?
Well, what are my square roots?
Square root of 7.
Square root of 7 and square root of 5 identical?
No.
No. So can I add these?
No.
No. And that's irrelevant of the whole can you add 6x squared and 4x. We didn't even hit that point because can you add square root of 7 and square root of 5? No, they'd have to be like radicals, and they're not because their bases are not the same. So, cannot be combined. And if I say cannot be combined, my reasoning on this one, we talked about the bases not being the same. The official vocabulary is the radicands are not the same. So the radicand refers to the number under the radical. So I'm going to write in here that the radicands are different. So thoughts on C when you're ready. 12 cube root of 7xy minus 8 cube root of 7xy. So what are we going to get?
4.
Root of 7xy.
Okay. 12 of something minus 8 of something is 4 of something, and so it's going to be 4 cube root of 7xy.
As of right now, I'm going to get less than 11.
I don't think I'm gonna like it because it says it again. That means there's gonna be problems that take a while.
Just means I'm not getting through all the material today, so. Okay, D. 7 cube root of 5 minus 4 square root of 5. Okay, so we have a cube root and a square root. In order to add or subtract, the radicals have to be identical. These aren't the same type of root, so cannot be combined. Do you remember the vocabulary for what that is? It's different. Index. Radicand is the number under the radical. Index is the little number that refers to what type of root it is. So I'm going to say that the indexes are different. Or someone said last period, why can't we just say, or I just want to say small numbers are different, or little numbers are different. I get it. I totally get where you're coming from. As your math teacher, though, I'm trying to teach you appropriate vocabulary. So, true.
You know what?
3x square root of xy plus 4x square root of xy.
7x square root of xy.
3x plus 4x is 7x, and the radical just tags along. So 7x square root of xy.
Yep.
17 times the fifth root of 3x squared minus 15 times the fifth root of 3x squared. So 17 of something minus 15 of something is 2 of something, and that something is the fifth root of 3x squared. Okay, you got the basics.
So let's say, will we have to use absolute value for nearby answers? Do you think?
I don't think so.
Okay.
Okay.
This is slightly off topic for a second, but are we going to have time at the end for you to help me on the last one?
I could try.
Oh, this looks fun. There's a box net thing. Fence.
That is on the window.
A stained glass window. This one. Can I color it?
Okay, so the following is a picture of a stained glass window made up of square pieces and portions of square pieces. If the side of each square measures 5 inches, find the perimeter of the window. So the whole big rectangle is a window. The design is squares that is the stained glass. And what's it say about these squares?
Each square measures 5 inches.
Okay,
Except for the half squares.
the side of each square measures 5 inches. So like if I start looking at this square here, there's a side of 5, a side of 5. If I go over here, there's a side of 5,
So we can just count it.
side of 5. So all of those squares have sides of 5. Now, the question is, what is this length here? So I'm asking what length that is. So think about what portion of the square that is.
What number is that you wrote? Because I cannot see that.
No, wait.
I wrote, this is a question mark right here.
Oh, okay.
5, 5, 5, 5. That's a question mark. Because,
And you know,
I actually am good at that.
Or it's A plus B squared plus B squared.
Yeah.
Okay, so,
B squared is equal to
okay guys, so let's talk about where she came up with this Pythagorean theorem idea. These are all squares, right? So if I draw you a square over here to get you thinking. And what is this line? This is the diagonal. So this piece right here is the diagonal. On each of these squares, we know that the sides are all 5. And because it's a square, we know the corners are right angles. So by drawing that diagonal, we've chopped our square into 2 equal triangles. And so in order to find that diagonal, we are going to talk about our Pythagorean theorem. A squared plus B squared equals C squared. What do we know? A and B. A and B are the legs that meet at a right angle. And so my A and B are 5 and 5. So 5 squared plus 5 squared. And then we're trying to find this middle piece, right? Which we can call it C if you want. You can call it X. So 5 squared plus 5 squared equals C squared. 5 squared is 25. So 25 plus 25 is 50. So I have 50 equals C squared. Take the square root. And the square root of 50
The decimal, I got 7.07.
is a decimal.
You're gonna have to find the I is a decimal.
Okay.
So we're gonna divide it into the paper.
Okay, it's a decimal. However, square root of 50.
it's going to be
Are there any perfect squares in square root of 50?
25.
Because if I have 50 cents in my pocket, I might have 2 quarters. So 50 is 25 times 2. And so the square root of 25 is 5, and the square root of 2 stays square root of 2. So now I know that this diagonal is 5 square root of 2. Which means I know this piece up here is 5 square root of 2. So lots of different ways to finish it up. What do you know about the length of this window? Okay. And so if she's saying 3 units, 1 unit here is 5 square root of 2. There's a 5 square root of 2 and 5 square root of 2. So what is that total length of the window? 15 square root of 2. And then have you figured out your width? The width has 2 of them, right? So 5 square root of 2 plus 5 square root of 2 is 10 square root of 2. And what were we asked to find? Perimeter. How do you find perimeter?
Length times width.
You add all this.
Add all the sides up.
Oh, I got it.
So length plus width. Or if you want to think 2 length plus 2 width. Again, lots of different ways to finish this one off. But it's the idea of adding all the sides up. Okay, so however you want to finish this up, you know, everyone thinks perimeter differently. Someone this last class said, can't we just count all the count all the pieces up? You can. Some people wanted to do 2L plus 2W. I just wrote it out. So 15 square root of 2 plus 15 square root of 2 plus 10 square root of 2 plus 10 square root of 2. however you get there, it's all going to add up to be 50 square root of 2. Now, in this type of problem, possibility you could be expected to give a decimal answer. Can your calculator do that for you? Yes. I will say, know how to use your calculator in that situation. For me, I can just type 50 square root of 2 if I want, and it'll work for me like that. Okay. So if you change it around and do like your square root of 2 first, you either have to end your parenthesis, and then you can do times 50, and I would still get that 70.7. Or I could do square root of 2, hit equals, and then times 50. It all comes down to knowing how some of your calculators are a little different too. You have to do things a little backwards. So know how to use your calculator is what it comes down to. So this is approximately, if you have to give a decimal, 70.7 inches. Questions? Moving along then. Example 3. Square root of 12 plus square root of 75 minus square root of 3. Okay, so in the form it's in, can I add those radicals? No, because they're not like radicals. I'm going to tell you up front. Some of you guys are going to kill me on this upcoming quiz and test because some of you are going to do just that and say, oh, square root of 84. Okay? They're not like radicals, so I cannot add or subtract them as is. However,
you can
blue paper time. Just wait and see. Okay, so square root of 12. Does 12 have a perfect square in it? 12 has a 4 in it. So square root of 12, if I write it out my way, has a 4 in it, which means I'm going to write it as 4 times 3. What do you know about the square root of 4? It's 2, so that goes out front. What about the square root of 3? Stays as is.
Oh, I got it.
Square root of 75. If I have 75 cents in my pocket, I might just have 3 quarters. And 3 quarters is important because 25 is a perfect square. Okay, so 75 is 25 times 3. The square root of 25 is 5. The square root of 3 stays square root of 3. Minus. What about the square root of 3?
It stays like that. Then we can add and subtract.
Okay. There's no perfect squares in 3. It's just 1 times 3, so it just stays square root of 3. Now, it's okay that it stays square root of 3 because they're all the same now, aren't they?
Is there a 1 in front? There's a 1 in front. 6.
So it'll be 6 square root of 3.
Okay. If there's no coefficient or number in front of the square root, assume the invisible 1. So 2 square root of 3 plus 5 square root of 3 minus 1 square root of 3?
6 square root.
6 square root of 3. The idea of 2 of something plus 5 of something minus 1 of something is 6 of something. So are we okay with that one?
Yes.
This is a lot easier.
Some of it is you guys are just getting practice with this too.
Practice makes perfect.
So. Okay, B. What's the big difference with B? We've got to notice right away.
It's a cube.
Okay, we are in cube root world, so pay attention to your cubes. Cover up the squares if you need to. Cube root of 250. Is it a perfect cube?
No.
No. So if we start checking, does 250 divide by 216? No. Does 250 divide by 125?
Yes.
Yes. Okay, so cube root of 250 is 125, and it's times 2. What is the cube root of 125?
5.
5. And then the cube root of 2 stays 2. Cube root of 54. Is it a perfect cube? No. Can 54 divide by either 27 or 8? 54 divides by 27. So I'm going to write it as the cube root of 27 times 2. Cube root of 27 is 3. Cube root of 27 is 3, so it's going to be 3 cube root of 2 minus cube root of 16. Can I do the cube root of 16?
No.
Cube root of 16 I can't do, but what does 16 divide by? 8. And so 16 is the same as 8 times 2. The cube root of 8 is 2. So it's going to be 2 cube root of 2. 5 cube root of 2 plus 3 cube root of 2 minus 2 cube root of 2.
6 cube root.
6 cube root of 2. As you have already learned, the hardest part of this problem is when you enter your answer, make sure you put the little 3 on there for the cube root, right? And when you do the quiz and test, when you do my quizzes and tests, same thing. You have to remember to write that little 3 if you want full credit. Yes?
For these, if I wanted to, like, once I get the first, like, thing down, like, we did 16 root of 250, and I knew that the radical was 2, can I just go ahead and put 2 for the other radicals?
Not necessarily. Okay? Because there's a possibility that they may have a couple different radicals, and some of the pieces will add, but not all of the pieces will add. So don't always assume all of your radicals are going to end up the same. Okay, so the back side, we're going to start multiplying. And in order to multiply binomials, we have to FOIL. So, we need to review FOILing. So I'll go through with you to review. We start with F, which is first, and keep in mind it can be FOIL or distribute. So first is going to be the first thing in each parenthesis. 4 times 5? 20. Oh, outside. So that means you take the 4 and you distribute it to the other thing in the other parenthesis, or you're multiplying your outside terms. 4 times 4 square root of 2. The 4s are both numbered, just regular numbers, so 4 times 4 is 16. There's no other radical, so the radical 2 doesn't multiply anything, it just carries along. So it's going to be 16 square root of 2. Okay, we've distributed the 4 every place. Now it's time to distribute the 2 radical 2. We're doing our insides. 2 radical 2 times 5. You guys okay with that? You're multiplying the 2 and the 5 that are outsides, which is 10. Square root of 2 just carries along. So plus 10 square root of 2. And last, the last piece in each parenthesis, which in this case is 2 square root of 2 times 4 square root of 2. Okay. Let's go with 8 square root of 4 for the moment. We have a 2 and a 4 that are outside, right? 2 times 4 is 8. The radicals, square root of 2 times square root of 2 is going to be square root of 4. If you see the step past that, that's fine. You go ahead and jump there. Are we okay with what I've written so far? Okay. Cleanup steps. What kind of cleanup steps do you see?
You could combine 16 and 10.
Okay. Our middle 2 terms both have square root of 2's on them. So what is 16 square root of 2 plus 10 square root of 2? 26 square root of 2. Okay. What else do you see?
Your 4 is a perfect square, so you can make that into and multiply it with the 8 that's outside of this.
Okay. Square root of 4 is a perfect square. Don't leave a perfect square in your answer. So if you didn't already deal with it earlier, Zephanie wanted to deal with it earlier, and I took a moment. Okay. And that's fine if you dealt with it earlier. So square root of 4 is 2. 2 times 8 is 16. So this is really a plus 16 at the end. And then we still had a 20 at the beginning. So now we have 2 constants that can add. So 20 plus 16 is 36. Plus we still have 26 square root of 2. What is 36 plus 26 square root of 2?
Can't do that.
Good answer. Okay. They're not like terms. One has a square root of 2, the other doesn't. So this is as far as we go. Let's try B. 3 minus square root of 7 times 2 plus 4 square root of 5. Okay. 3 times 2 is first. 3 times 2 is 6. Outsides. 3 times 4 square root of 5. 12 square root of 5. Multiplying the outsides, the square root's along for the ride. Now it's insides. Negative square root of 7 times 2. Yeah. A negative times a positive is a negative. We have a whole number of 2 and a square root of 7. So minus 2 square root of 7. And last, negative square root of 7 times 4 square root of 5. Negative times positive makes it a negative. Are we okay with that? Minus 4, because there's a 4 outside. Then square root of 5 and square root of 7 makes it square root of 35. So I have minus 4 square root of 35. What's next? Okay. We attempt to combine like terms. Okay. As it is currently right now, I have a whole number 6, a square root of 5, square root of 7, square root of 35. None of them are alike right now. Square root of 5, does it simplify at all? Square root of 7? No. What about square root of 35?
Yeah.
It doesn't make it.
What's the only things that square root of 35 divides by? 7 and 5. And didn't we just talk about those aren't perfect squares either? It's done.
That was pretty simple.
That's gonna
It seems a little too easy.
It's done. How do you guys feel about stopping there?
I like it.
That's where my other classes ended. So,
Sure.
Oh, okay. I thought you meant.
I think we stopped here at the problem. And I was like, I don't like that. That's so many numbers.
well, that is where we have to end on that problem.
Well, yeah.
I mean, like, I get it. It's long. There's 4 pieces, but
I like it. It was fast.
no, I was talking about.
In a lesson today.
This is where my other 2 classes have ended, so
We should.
I'm going to stop here. Well, if you do C, I will check your answer. Homework, I will continue lesson tomorrow, so homework will be due on Thursday.